We're going to move on to lesson 3 called similarity in transformation. So how we can transform a shape that it doesn't exactly be the exact same like congruent, but it's similar. So name and date. Take a moment to read this comic. It's kind of fun. And then we'll move on to slide 2. It says that recall that a dilation changes the size of a figure by a scale factor, bigger, smaller, enlargement, or reduction. But it does not change the shape of the figure. Since the size is changed, the image and the preimage are not congruent. It says complete the graphic organizer, consider each word in the rating scale, and place a check in the appropriate column next to it. If you do not know the meaning of a word, find the meaning of the glossary. Now, I know what these mean, so if you don't know what they mean, please make sure you are looking that up. I do know that a dilation, what it means is an enlargement or reduction of an image. The scale factor, I know it well. It's how much the image is enlarged or reduced. And the last one is similar figures. That one is probably more new this lesson. And that would be shapes that are not congruent, but have the same shape. Usually similar figures are, there's a P word that we'll talk about later, proportional. Okay, so slide 3. It says 2 figures are similar if the second can be obtained from a first by a sequence of transformations and dilations. So this one we're going to focus on dilations as well. So, and they have to be, I'm going to write the word here, proportional to be similar. The sides do. So it says determine if the 2 triangles are similar using transformation. It gives us a hint. Since the orientation of the figures is the same, one of the transformations is a translation. So we just slid it over and we got it bigger. So the other one would be a dilation. There's one of them. I'm going to do another one, dilation. These are usually going to have 2, and one of them is going to be a dilation. But we have to make sure it's a true dilation, which means that we have to make sure our sides are corresponding. So we have a length of 3 here, and then we have a length of, on the bottom, 1, 2, 3, 4, 5, 6. So far this is twice as big, or half as big, if you want to look at it that way. So 1, 2, 3, 4. This one's 4. If this one's 4, this one better be 8 to keep going along with that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And it is 8. So since 2 of the sides of the triangle are the same in proportion, twice as big, that means that the other side will automatically be that. And we could do the Pythagorean theorem to figure that out. This is going to be a 3, 4, 5. 3, 4, 5, but double it, it's going to be 10. So we have a dilation of 2. I'm going to go from little to big. If you wanted to say a half, you could, but there's no primes to tell us which one is the second figure. Okay, so slide 2, determine if the 2 rectangles are similar by using transformation. The orientation of the figures is different, so one of them is a rotation. It looks like we took it and we rotated it on W, so we just kind of flipped it around. Rotated it on W. Yeah. And then this, we had a smaller one, and then it got bigger, so this would be, again, a dilation. But we have to make sure it's a true dilation. So check our side lengths. This is 3 and 3. This one is 1, 2, 3, 4. This is 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5, 6, 7. Is that right? 1, 2, 3, 4, 5, 6, 7. So these, if we put the sides together, we would have 3/4 and 5/7. These are not equal, so this is not going to be similar. So there is a dilation, but it's not a true. We can't obtain from 3 to 4, that's 3/4 or 0.75. And 5 to 7 is not the same as 3/4. So it's not a true dilation. So these are not similar. We have to check those sides, though, to make sure that they're in proportion. And why are they not similar? They're not proportional. Our fractions don't reduce to the same thing. Okay, so let's try a few more where we're checking side lengths here. Looks like this one would be by a series of transformations. The transformations that would get us there are going to be a reflection. Looks like we would reflect across this line, a vertical reflection. So I'm just going to write a vertical reflection because we don't know where it's at on a coordinate plane. And then we got bigger, so it would be a dilation. But we need to check that dilation. So S to T is 3. The corresponding with that would be 1, 2, 3, 4, 5, 6, P to Q. Okay, let's check this other flat side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Twice as big, twice as big. So its dilation is of 2 or half. And it's a true similar. So, and I guess I should have been better about a similarity statement. So a similarity statement, if they are similar, we can write those. We'll go EDF, triangle EDF, this is back on slide 3, similar to HGI, triangle HGI. Now this one was not similar, no similarity statement. This one is similar, so let's write a similarity statement. We'll go STU, triangle STU is similar to, S goes with P, so PQR, triangle. So there would be our similarity statement. Okay, so on B, we've got 2 trapezoids here, so we need to see what would happen. So because it's, how do they phrase it over here? It says, since the orientation is the same, one of the transformations is a translation because it's just shifted up. So this would be a translation and then a dilation. Let's check to see if it's a true dilation. So A to B is 3, E to F is 2. So everything should simplify to 3 over 2 or 2/3. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4. So if we put the corresponding sides over each other, 2 to 3 is 2/3. 4 to 5 is not the same as 2/3. So this is not a true dilation. These are not similar. So there is no similarity statement. These are not proportional. And we could write that with 2/3 does not equal 4/5. Little over big, little over big. And same thing here. We could have said 3 over 4 does not equal 5 over 7. I should have maybe said that a little earlier. Sorry about that. Okay, so on this last couple slides, it says use the scale factor. Similar figures have the same shape, but they have different sizes. The sizes of the 2 figures are related to the scale factor of the dilation. The scale factor tells you that it's proportional. So we've talked about this before. Between 0 and 1, it's going to get smaller. Equal to 1, it's going to be the same. And that's the same as saying congruent. And greater than 1, it's going to get larger. So we've seen that before in Chapter 6. So on slide 7, a couple word problems. An art show offers different size prints of the same printing. The original print measures 24 by 30. The printer enlarges the original by a scale factor of 1.5 and then enlarges the second image to a scale factor of 3. So it gets bigger and then bigger again. What are the dimensions of the largest print? Are both of the enlarged prints similar? So what of the largest print? So we need to take our 24 and 30, 24 by 30. I'm just going to write it like this. And then we need to get it 1.5 times bigger. So if I take both of these numbers times 1.5, this would be 24 plus 12, 36, by 30.5 is 15, so 45. But then it says we get this bigger by a scale factor of 3. So I'm going to write a big times 3 over here. 36 times 3, 90, 108 centimeters by 90, 125, 120, 135, 135 centimeters. So here's our enlarged image. Are they both similar? yes, they are dilated. So they are similar. The scale factor is the dilation of 1.5 and 3. So another practice, a t-shirt iron-on measures 2 inches by 1 inch. It is enlarged by a scale factor of 3 for the back of the shirt. The second iron is enlarged by a scale factor of 2 for the front of the shirt. What are the dimensions of the largest iron-on? So 3 times bigger than 2 times bigger. So really it's like 6 times bigger. Are both of the enlarged iron-ons similar to the original? So, well, the answer is going to be yes. They are 6 times bigger, or you could say dilated with a scale factor of 6. Larger. Dilation of 6. Another way of writing it. So we just need to figure out the final one. 2 by 1, then we take that times 6. So you can get a 12 inches, yep, by 6 inches for the final dilation. And there you have it. And it's okay to combine scale factors because you're just multiplying. And multiplying has that property that allows that to do that. So we're good there. Hope is a little voice you hear whisper, maybe, when it seems like the whole world is shouting no. Have a great day.